Okay guys, welcome to gRPC SLab. First of all, before we start, I want to learn your ambition on gRPC. If you guys have ever checked what is gRPC is, or did you ever write a service? Maybe I can start first. Before joining Cytec, I used to work in a company called Crumpub, and our tech stack is basically using gRPC service for all internal and external communications. So over a year, we have made like 15 different gRPC service integration, and there are some pitfalls, of course, going on the gRPC or REST, but there are also big advantages. So I will try to cover all of them, and at the end of this workshop, everybody should create a gRPC service and testing it, both streaming and asynchronous calls and synchronous calls. So, does anyone want to start? Have any experience on gRPC or ambition about that?
I know gRPC, I used gRPC in the past, so I'm expecting this an enhanced version developed by Google.
Mm-hmm.
So I don't think it would be a major difference in the regular concepts of RPC.
What you mean by you used gRPC? Did you use gRPC
I used
for
RPC.
RPC.
Yeah, RPC.
Yeah.
That's the
So I expect the concept to be the same.
Okay. So our SLab will be first going on slide, just the theoretic information, mostly from directly from Google, some quotes. After that, we will also have a video, which is optional. Maybe we can skip that one, which is a session from a Signal event, which a guy is pretty passionate about gRPC. So I didn't include it in as mandatory because it's just not mentioning about pitfalls of the gRPC. And meantime, we will have a blog post about Out0, which they compare JSON with the protobuf in detail. Then we will have a reference implementation. I will share the repo with you guys, which is basically a couple of gRPC service implementation, including with the interceptors. And then we will have a workshop afterwards that there are 11 steps, which is starting pretty basic, and then it's become more detailed. So first, talk about what gRPC is. This is a definition directly from gRPC.io. gRPC is high performance, open source, universal RPC framework. Basically, Google claims that all stack is covered by them. So after you run a gRPC service in your code base, like it could be inside a Spring framework or plain Java application or Node.js, PHP, it doesn't matter. They take care of all the high performance stack thing, and every part of gRPC is open source, so you can make extensions, you can create your own stuff, or you can change anything in the implementation. And
maybe it's an early question, but do they have different implementations for different languages?
No, but with the gRPC you can create your server code and client stubs, and they are okay for 7 different languages right now.
You can generate for different languages.
Yes.
Yeah.
Is this protocol the Google Web Toolkit is using?
All of the Google services underneath. I think that will be cover your question right now. gRPC is what they call is production-ready version of what Google use internally for all RPC communications. So the story is this: Google not using gRPC, Google using Stubby. Stubby is directly created by Google, like maybe 10 years ago, for their microservice communications. So internally, all streaming services or everything like sends a payload and receives a payload using Stubby. But Stubby is created way before than HTTP2 standards are defined. So what Google decided is they rewrite the Stubby with the also taking care of the HTTP2 standards. So they redesigned their all general purpose RPC. The important thing is here, they always mention that it's a general purpose, because in basic use cases, like even at the streaming, they're mostly focused on, instead of like pluggability or something like that, it should be perform well. It should be always perform better than REST. This is what is their claim, and we will see if they are doing it or not. And the motivation behind it is basically after Google is proved in their infrastructure, and how they use the Stubby. As I mentioned, they decided to go over the newly advertised like CPD or HTTP and Quick, which is a really beneficial features on HTTP2. And they even designed this to make in the Internet of Things device, like it's not source greedy thing to run a gRPC. Like you can run it on Raspberry Pi super easily. And there are a couple of principles while they are creating new open source version of the Stubby. They are keeping some things in their mind. First of all, it's a bit look like more to swap services instead of REST services. So they are using services, not objects, and messages, not references. This is covering lots of stuff, and we will see soon. Coverage and simplicity. Their mostly aim is gRPC is kind of universal thing. So if you are writing PHP, you can still use gRPC or Ruby or whatever language you are trying to do. Also, it exists on Microsoft Stack, and it's not really source greedy. So even with small resources, you can gRPC server itself can scale it up and down easily. It's free and open, and it will gonna stay like this. Also, there are lots of open source contribution on gRPC stack. Like for example, it's a kind of a, we will see plug and play thing. Like for example, you can easily integrate with a metric library or DDoS protection library by integrating basic gRPC interceptors. It's general purpose, so it's not generally focusing on a specific feature, but as I mentioned, it's pluggable, so you can make it work in your environment, like for example, LDAP authentication or whatever you are using on your services. It's layered, and its stack is easy to understand as outside. Like for example, developing an Android application, every activity has a life cycle. A gRPC call has also life cycle. Like before the call invocated or payload being de-encoded, before that there are lots of steps included. For example, it has a own natural protection on DDoS, because if a client is making a request from an ant which has causing a problem inside the server, gRPC is automatically lower the response rate of that IP address. So it's basically have some protection inside, and since it's layered, you can easily see in what phases of the request is going by on the server side. It's payload agnostic, so as default, it's using protobuf for communication, which is much more efficient than the JSON, XML, or whatever you guys use so far. And even if you have a system that only capable of parsing JSON, you can do that with gRPC. You can change the payload. Of course, you can do it on the REST service as well, so it's not much difference. So it's not force you to use the same thing. The streaming is one of the most important things on gRPC, because since it's developed with the standards of HTTP2, streaming is supported on both client side and server side, which is super easy. We will see that. When you create a basic gRPC service, the client side has ability to create synchronous and asynchronous steps. So basically, if you want to make your services non-blocking, it's just super easy. Just use the generated client's non-blocking client version. It's cancellation and timeout. Those parameters are easily configured on both server side and client side. And as well, you can cancel any request, even it's be a streaming service or it's just a newly created service. When you kill something, gRPC is completely responsible on killing all the resources tied to that, even if it's a Spring framework. It will gonna instantaneously kill the thread, and it will be free up the resources. Lame ducking is basically supported for gRPC. So when you're closing your service, for example, shutdown or restart, it basically not accept new requests until everything is processed. So basically, for example, in Spring, if you are using Spring and gRPC together, after every context of Spring is destroyed, you can just ask gRPC to close itself. And flow protection, we already go over it. Pluggable, I already go over it. Extension as APIs, this is the main idea. Like Google is delivering the all gRPC stack, and you can do extensions wherever you want. Metadata exchange is it's more required when you compare with the REST services, because if you are using protobuf, if the version of the proto is changed, the message, if they are not compatible, you generally, there is no way to parse that binary serialized payload. So metadata is super important when communicating with the gRPC service. With this, without calling the service or without causing any problem on the system level, you can just exchange your metadata and understand the version of the service or any special toolkit, what do you want to do. Could be done.
And the metadata is part of the payload, or it's
No,
somewhere?
it's separate. Yeah.
Okay.
And there is standardized status codes. Like in HTTP, for example, we have some standard codes for example, internal server error or resource created, some kind of things. In gRPC stack, the basic idea, not authenticated or resource exhausted, too many request things are already in the gRPC stack, and you can extend this one super easily. You can add your own code. Like it's not possible to add HTTP codes on your own, but it's possible on gRPC level. We will see. Basically, this is what it looks like. What we see here is we have a C++ service. So basically, first you create a proto file. With that proto file, you create the server code and server steps. So in this example, server-side code is generated for C++ service, which the clients are using on Ruby and Android. This is not your concern totally, because when you create your proto file, you don't need to think about the client side, because you can generate your client easily, like in 20 different languages, and the use cases are like super familiar with each other. It's basically the same thing is generated. So if you go over the key points of gRPC, it's basically use protobuffers, which is a powerful binary serialization toolset and a language. You basically create your payload messages with protobuf, and as well you type your services with using protocol proto syntax. It automatically generates client and server stubs. Those are the including languages right now, but this is not limited and is getting more popular each day, and more languages will be supported. And bidirectional streaming and fully integrated pluggable authentication, which HTTP2 is in place. So this is coming from a blog post. It's really say, on the REST side, you have simplicity, because most of the payloads, if you are working on non-compressed environment, it's humanly readable, like JSON is super easy to read. But on gRPC, and also you have Swagger, you have lots of tools, Postman to test the data. In gRPC side, you are a little bit alone. It's performant, okay, but you cannot read the messages, payload messages, for example. It's not human readable. You need to parse with the proto file. Or, for example, a client is saying that they are having an exception on their gRPC server. You cannot ask them to send the request response objects. They can only send you the proto file. So you can match on that level, or you need to have more logging in your system to figure it out. Or if you want to call your own service, you either need to write a JUnit test, or you need to generate the client code, and then, for example, with a jar, you can call your service. And this is the most general thing to, what can I say? The rest, mainly I will check with swap services with gRPC, compare them with each other. But nowadays everybody is using REST in most cases. So in gRPC examples, they are also going over this example. At REST, you can also use HTTP2 as well as HTTP1. But the most benefits coming with the HTTP2 is not yet in the stack of REST services. Basically, like for example, the streaming. You can do it, but it's require much more work than if you compare with gRPC. And there are basic methods. I think everybody in here used REST before. On the gRPC side, it's basically open source and bidirectional streaming, which is cross-language unirecalls. I think this definition is pretty general because REST is also cross-language stream. I think the most important part is again protobuf versus JSON comparison. But as mentioned, for example, you can change the payload of a REST service. So even you don't want to use gRPC, you can use protobuf in your REST services. But gRPC is generally, if JSON, for example, is a standard for REST, everybody stands to using that. On gRPC side, its definition is basically protobuf is their defaults. So most of the people will probably use protobuf here. And this is this is coming from a presentation on Google Cloud event this year. What they are saying is basically protobuf, the serialization is much faster. We will see the comparison. And since it's compressed and its binary comparison is used, is much more smaller payloads. So if you look on monolith application, there is not much difference because you just need to parse that JSON object just 2 times. But in the microservice environment, you will probably dependent on more down-layer servers. So this impact will be much clear to you. So what are the protobuf? It's basically much more structured if you compare with REST, but it's basically looking like XML, which is much more up-to-date, faster, and simpler. You just need to structure your data or message once, and you can generate every code from there, like for example PHP code or Java code or whatever. And since it's structured, it's much easier to use. So we have an example here.
By the way, JSON is so structured. What's the difference?
But it's not defined like that. For example, you
have a
can
schema, you mean?
yes, you
Okay.
can add a new parameter. You can also add that on protobuf.
Okay, so you have a schema.
Yeah.
Okay.
So this is what a basic proto message looks like. But before going over the special characters, there's a cheat sheet here, which is super easy to compare. The left-hand side is the data types that you can use on the proto files, and this is the representation on the environments. For example, int 64 will be cast to long on Java code, but 32 will be integer, which is probably super straightforward. But it's really good to have that comparison and what is the advantages and disadvantages over that. So let's go over messages. In here, we have a message called person, basically. You just start adding fields. This part is optional. So if it will be required, then in the this basically, for example, if you generate Java code from here, it will be a builder pattern. So that builder pattern, if you not putting the name in it, it will give an exception basically. But for email, it doesn't complain anything. And inside, so required field, and then field type, naming, and you need to do this ID thing, and it should be you should be really careful about versioning stuff. For example, if you switch 1 and 2 here, basically since it's a binary serialization, the name will not be there. So when this message will be synchronized, the first parameter will be name, second parameter will be ID. So if you play with those, then your message will not be parsable anymore. So you should be careful. For example, if you remove this,
using this protocol in some WebSockets, and it's very hard to keep a versioning. It gets very complicated when your model changes, and it's very hard to debug the changes because it's binary. You need to have need to keep the binary, and you need to translate it into a readable text to debug it. It was a bit hard. Yes, it was efficient.
For debugging, you can use plain text as well. It's also possible, like in production environment, you generally don't use it.
Yes,
but in test
problems occur in production, and you need to solve it.
But do you have a schema registry for this, or it's just?
No, this is just a proto message. You will save this message as person that
I thought
proto.
This is kind of schema, no?
Yeah, it's the schema. It's the proto tree syntax. It's basically like this. But we will see more deeply in the upcoming examples.
Sorry again, this is not language specific. This is just a schema of proto something that if you call it schema,
This is proto tree language. This is proto language.
So it's not the.
This is a schema. You define out.
Yes.
So it's the schema of the person.
And this you can generate a Java code, basically person class or C#, whatever.
So it's the schema.
And either you can declare some types in here or outside of the message. It's both okay. So in here, our first parameter is name, then ID and email, and then there's a definition of enum, and then a phone number object, and phone number finally included in here as a fourth parameter. So for example, you want to remove the email. What you should do, like you can remove this line, but you shouldn't change this 4 into 3. So it should be deprecated somehow. You will never use it. And there is, I think it's like going on 100,000 of fields. So it's pretty safe to just raise it. And there's as well some
of course, you
resort
assume
ones.
that there are clients still using the old version of the.
You need to be backward compatible.
Like for example, if you remove email and client will gonna keep sending email, it won't be a problem. No, it won't be a problem. It will be just ignored.
No, I mean if the clients are using old schema,
yes.
it will be a problem.
No, it's not. It will not gonna cause any problem.
It's optional, so it shouldn't.
No, if you change the number. If
But
you make 4
you mean the number?
Yeah, if you change 4 into 3, then it's not parsable anymore. But if you just remove email and keep the IDs as it is, then it will be ignored, that parameter. Or the newly added ones also. It's exactly as JSON, like ignore the not
if you are
related
in
standard.
the development cycle, not release to production, just keep it 3, make it 3.
If you don't have consumers at the
Yes,
moment.
yes.
Yeah.
But it's a bit annoying, this thing, to have these numbers. Why
Yeah.
they did it?
Like-
Payback for the efficiency.
But for example, after working in a company for a year, I really enjoy using this because, for example, in REST services, you create the objects on server side, and then when you're using the clients, on the client side, you need to create that objects again and again and again. You can either package them, but it's much simpler just including a proto and generate the code.
So let's say, for instance, you remove the email and then change the phone number to 3.
Yes.
When do you detect the issue? At runtime, when the client is
The thing
consuming?
is, if
At runtime, when client
And,
it's
if
like
it-
JSON at the end.
it's a nasty problem, by the way. If this phone number is not an object and it's a string, and you will not sense
You
anything.
will not, yeah.
You will see the
will not
email in
notice
the
it.
phone.
Yeah.
But if the type is different, then it's not castable anymore.
What you must do is, what we were doing is, when you have an exception, we save the binary and we wrote a desktop application. You open the binary file, the payload, in that application, it parses it. If it
Yeah.
can.
Yeah.
If it can, because maybe it is using the old schema as well.
That's true.
This is annoying for a developer, but
It needs a very
This
good
is,
management.
in my opinion, this is not annoying for developer. This is annoying for data analyst people. Like, you imagine a data lake. You are just sending your proto files, and
Yeah, but-
if you're not keeping the version of which proto that payload,
but at
you
the
don't
end you are
use proto
responsible
file.
because you are building it. No?
Yeah.
It certainly makes things complicated.
Maybe it has other
No,
advantages.
it's for sure, but it has advantages of efficiency.
Okay.
If you have 20 million users making hundreds of requests per second, then you have to use it. But
For
yes, it makes
yeah,
things
for
complicated.
high load it's
Or for example, my best way is basically create your REST environment, write your REST services, and eventually when you are going to production, just take a couple of times to switch it to gRPC. It's possible, you can do that. For example, maybe in the code we will understand better, but if you are using, for example, Spring services, on the controller level you are just including that Spring service and using it. So it's super easy to switch gRPC on that point.
Okay.
So in the development environment it will be much easier, but on the production you
But
can
then the
benefit
plan-
of the
but then
performance.
the plan needs to be coded, and if I switch to gRPC.
Yeah, but it's not
Okay.
super hard. We will see that. So basic comparison. Of course, that proto message I think much simpler than XML messages, and they are 3 to 10 times smaller, 20 to 100 times faster, less ambitious on resources, generate data access classes that are easier to use programmatically as the builder pattern. Sorry. And this is not a binary version, but as a comparison, this is what gRPC is sending. Basically, they know the payload, so person will not be sent, name will not be sent. Instead, it will be a binary, just one, the field ID, and email will be two, basically. And even in this message, if they compare it with a, I think it should be uncompressed environment, the proto message will be 28 bytes, and it will be 69, which is more than 2 times bigger, even if you remove the white spaces. And the parsing time is incredibly much on XML side, because XML as a syntax is much harder to parse it. So I think nobody cares about XML. I don't care, basically.
Yeah.
The most important is protobuf versus JSON. I didn't take the parse of the their blog post, which is great, I think. They made the kind of a good comparison between both of them. This is the first claim. This is what they end up. It's 6 times faster than, and let's see how they do the testing. I will include the slides so you can go over the post again. So what they basically do is, it's quite same as our example because it's coming from gRPC site. They are creating 50,000 of people, and they are including in a GET request, and both they are trying protobuf format. This is not about gRPC at all. This is protobuf versus JSON, and they are sending it. And on the post, they try the same, like 50,000 people, but they couldn't achieve that result. And we will see. They are mentioning it. They are just using 50 instead of 50,000 on the post requests. And here is the comparison. I forget the name. Comparison. This is a compressed environment. This is milliseconds. How much time does it need to be parsed? And this is purely on front end. So
what does it mean, compressed environment?
it's encoded environment. So gzip, for example, for the payload request, it's zipped, not clear text. And they are doing it on the front end side. So basically, even it's a protobuf message, it has to be after serialized. It has to be turned into JSON to be used on the site. So that comparison is also included in here. So size is nothing much difference. Sorry, the parsing time is just 6 or 5%, I think, 4%. And the payload is much smaller, so network impact will be less, but it still doesn't worth the whole hassle, in my opinion. In non-compressive environment, when the clear text is sent through the JSON, then the difference is quite realizable, especially on the size of the payload. It's like 21% is 34% smaller and 21% less time is required. And in the post, we will see it's the requests are 50, so lower, in a lower size. There is much difference again. And then they switch to Java communication. The important part is when you do the Java to Java communication, you don't need to serialize it again to JSON object. So it will be just purely after gRPC done its transmission, it will be just converted to a Java object. And now it's super clear that the gRPC is just doing things much better. It's like 5 times faster of your. So imagine in a microservice environment, even if you don't use gRPC outside, you can consider it using inside. I mean protobuf. And here is what they use. It's quite same as our example. So basically the only language is Proto2. If you want to use Proto3, you need to mention it on the first syntax, like maybe after Proto4 is launched, you need to mention that syntax. And you will give a package name. This is optional, of course, but then your generated code will be under protofiles will be under that package. And this is the optional Java package name, so it will be created under this package. There's a people object. Now we see the repeated field. It's basically for list purposes. All you need to do is put a repeated field. And the people is depending on person, and person depending on the address. So it's becoming a bit bigger. And this is basically how you create after you use the CLI tool of Proto. You just generate and you give the address of the Proto file. It's just generate your code outside. But there are lots of Maven plugins and Gradle plugins, so you don't need to do it normally like this. And this is basically how it will be translated to the Java code. Basically, you just make a new builder and you follow the builder pattern, which is pretty nice in my opinion. And this is the dependencies that you need to use the Proto file. And also it's going on the front-end side, how you do the things with Node.js, but I'm just picking this one, so if you are guys into this one, you can turn back. And this is a link of the signal event that a nice gRPC talk, but in my opinion, the guy is like really don't want to write any code in REST anymore, so I don't know, it's kind of fanatic video, but it's if you guys want we can watch, but it's 25 minutes, so it's better to leave it later on. So here's our workshop repository. You guys can go and take the code. This is the moment that you guys need to download the code.
Oh, I'll work with you if it's okay. Because
My
I will
battery.
bring
You
my
guys still have
laptop.
battery? Yeah. Let me check.
And now we will go over a reference implementation on my site. I will explain through the code, which will be much better than the presentations, I think.
Anybody who's
More squeak, wise, right?
Can gRPC be used also with other binary encoders? gRPC can, you told that you by default uses protobuf, no?
Mm-hmm.
Or
The
you
default
can-
one is protobuf,
Yeah,
but you can use JSON.
But
as
even
well.
other binary encoders as well?
Yeah, sure.
Yeah?
Whatever you want. JSON, XML, it's all supported. It's payload
No, but
agnostic.
not text encoding, I mean still binary encoding.
Yeah, it's payload agnostic, like whatever you want.
Okay.
As long as you can deserialize it on the client side.
Yeah.
Because it will again give you the binary unserialized response, whatever you are using. And then you need to reserialize it on the client side.
Yeah.
So can we say that the primary strength about gRPC is just it can compress the payload on the transmitting side and decompress it back? Or
No, it's doing lots of things basically. Like for example, imagine a microservice environment. Your X service is calling Y service. And with HTTP2, you don't need to repeat the headers, for example, again and again like security headers. Those will be thrown out. And if you are using protobuf, your payload will be much smaller. And since it's completely all stack is managed by Google, you don't need to care about anything like adding more threads or adding more things on your server. It's automatically managed. So in your like developer's perspective, you don't need to do anything. You just type start gRPC server, that's all. And then you register your service in it. And that's all taken care of. You don't need to do any additional setting or something like that.
But mainly because you compress the data before sending it, it takes less amount of traffic.
Yes,
between the servers.
yes.
And they can.
It's not compressed, by the way. It's binary serialization. So the binary serialization is much more faster than, for example, in JSON, it's a textual representation of your data with the JSON syntax, and then it's serialized again to binary because it needs to go over the network. So you do it twice, but in gRPC it's just one iteration. Are we okay? Everybody get the address?
Yeah, sure.
Okay, when you guys switch to repository, you will see two branches. One is slab, which is the workshop address, and the other one is the master branch, which basically has a reference implementation.
No, thanks. I'll wait for the dinner.
I am sorry.
Hopefully.
Jamesh?
Thank you.
No? Yeah. Now I have a big pipeline.
So let's start building our source. I assume that will be same on your end, guys.
What is a local interceptor? Do you log the binary protobuf thing?
No, not binary, but I'm parsing it
But then
with the logger interceptor with a callback after the protobuf, like the gRPC stack down, this stuff.
after.
Yeah.
Okay.
I didn't understand. Can you repeat?
I will explain in a really good example. So we built our code. Let's jump. This is a Maven project. So let's jump directly in POM to understand what's going on with the project. Can you guys see it well? I think it's readable,
We
right?
can do there is a mode,
Bigger is better.
Presentation mode, right?
presentation mode,
Where
which
is
I
that?
never remember. View probably?
Window.
No, view probably. Enter presentation mode. Yeah.
Okay. In here it's just Spring Java 1.8 project. It's in my local it should be Java 11. I think it's no problem for gRPC. These three dependencies. One is for this one is for gRPC server. It should be included on the server code. This is the glue. This is the glue with gRPC with protobuf, and this is the required dependency for creating the stubs for the client side. And there are some other optional libraries like gRPC services is one of them. I haven't included the example with this one, but for example, this has reflection support for gRPC services. Why reflection is required? For example, you want a HTTP gateway, for example, in development environment. I don't want to test my service with gRPC. I want to use Swagger. So what should I do? There are lots of open source projects which is enabled by gRPC services. It basically enables the reflection on the server side with a configuration. Then all the gRPC endpoints could be seen outside. And with the additional libraries, they are just basically parsing JSON objects into gRPC and send the request. And when the payload is back, they just translate it in JSON again. So it will be perfectly working on Swagger. A little bit tweaks required to do or achieve that, but there are also lots of expansions on gRPC services.
So moving on, isn't the stuff something that you could generate just during the development time, or do you need it at runtime?
No, this is generally at compile time.
Compile time, yes.
Okay. But by this way, wouldn't this dependency be available at runtime? I think it's not needed that way.
Stop, you mean?
Yeah.
Yeah. You can just change the scope of this one.
Yeah, okay.
It's no problem. This is just an example right now.
Okay.
I think as far as I know, it's not required, but the neti and the protobuf is required for the runtime, of course. And this is a Spring Boot application. There is no need to use Spring with gRPC, but if you want, you can use. In this example, we have also REST resources, and we will compare the timing between them, the performance, I mean. Basically, Lombok dependencies, Spring Test dependencies. I don't want to use REST template. I use GNU REST library for testing purposes, so there is no advantage over the Spring framework. So we will see it clearly. And this is our build extension. Basically, protobuf is depending on, to generate code depending on the operating system. So in here it's Ubuntu, so this is required to be added as extension. And this is a basic, it's much clearer if you use Gradle, it's much easier. But this is basically a copy-paste code. And, okay, how can I exit this one? I don't like the presentation mode, I think. View, right? Exit. Let me see. Okay. As default, the protobuf plugin is looking resources under Java source main proto. This could be configurable. You can put your proto files elsewhere, or you can put them inside a jar and you can depend on them, or you can download from somewhere else. So in our example, as I mentioned, this is a greeting service, and it has an additional service called ping. But let's dive into what's into the greeting protocol. Is there a shortcut for presentation mode? No, I guess.
I think there is a shortcut with the command F1 to see the navigation side. Command F1. Or you have Windows Control F1 or Windows
No, it's
F1.
Ubuntu.
Windows F1. It doesn't work. Nah, okay, it's probably on the
Okay, television also cutting the first line. Okay, in our syntax, as I mentioned, you need to always put the proto3 because the language changed. And this is where there's an import here. We are importing another proto from the base package. Let's first go into that. There's a generic error message here. It's just holding, there's no service in here. It's an error message, which is basically the idea to include it in all error messages for the services, but there are another way to handle the error messages in here. So when we include this message, error message, could be reachable with the base.error message. So this is like a object-oriented way of defining things.
What is the syntax part at the beginning of this file?
Sorry?
Syntax statement, first one, line 1.
Version of the file that you have proto2.
Version of
For proto2, you don't need to put the proto2 as syntax. But after that, since it should be backward compatible, Google said you need to put this one on top. And you give the Java package here. If you give it nothing, then it will be a basic greeting request and greeting response on the top level. And we have 3 different RPC services. Basically, you the syntax is just putting a service and the service name behind it, and all of them will be RPC. By default, all of the gRPC service has to have a request and response object. Those cannot be null. We will see an example about that. There is 2 services which is identical operation. One is doing greet, one is greet or throw. In the first one, we will see that the error message, if an error happens, it will return this error message. On the other one, it will be more native gRPC stack. It will throw an exception on the client side. And there is another method, greet like steward. This is a streaming service. As you see on the right hand side, only different is you put a stream. So basically, when you call this service, the connection will not close until either party will cancel the request or it's finished streaming.
Does it mean for the last one, it's expected that the server will respond multiple times over the same connection?
Yes. For example, you ask for a stock, and when you send your request, a connection will be open, and server side will push, for example, each seconds the stock price, for example, to you, until either party should close the communication. Or, this is not included in this workshop, but you can also add stream here, then it becomes bidirectional streaming. It's basically like a WebSocket. It's much more fancy way of doing it. And then we have a enum here. So basically, if you have custom messages, for example, our greet service will greet Candas, but it will not greet Biber. If Biber will be sent, then we will have an error message. So it's a really good practice to have error messages inside your protofiles. It's not a must, but when you put that, it's more clear to understand like which kind of errors. It's also be same on the client side and the server side.
So if I'm stopping you too much,
No worries.
the streaming one, how does it get handled by the client? Is it like a publish subscribe scheme?
Yeah, we will see the whole examples
Okay.
with JUnit, unfortunately, but this is a real-time, real-world example.
Maybe just some tips. The error codes is a good idea. We were using this, and also same idea. For example, if you have a message, type, object, or whatever you call, and you have another object inside it, but it is dynamic, so you don't know what is it. For example, you have a comment object, and you have other comment types. So there are arrays repeated of comments, but you don't know what. So we were passing enums of comments so that you can serialize the inside of it.
Ah.
Was that clear? So you have an object message consists of other messages, but you don't know what are they. You cannot define it here because they are dynamic. You can put any other message. Do you understand?
No, I just now I'm confused.
Okay, I will after the it is a lot.
You mean like putting the enum inside the greet response, for example? Or
For example, in a game, if you have a message called comment, and this comment includes another object,
okay.
and there are a lot of messages like ping, I don't know, login, logout. This comment can contain many other messages. Do you understand?
Yeah.
But you don't know which includes.
Which version?
So it's dynamic, runtime. You don't know it. So you have 2 arrays. One is arrays of objects. The other one is the types of the objects.
Yeah.
So that you can pass on the server side.
The generated code, you mean? There
Yes.
is also the
Yes.
types.
It's
Alright.
the same pattern with this error code. So I just okay.
Alright, there's a strange proto file here, like empty proto. That is the main basic reason. We have another service called ping service.
You didn't open the empty one.
This, sorry?
Yeah, you didn't open the empty product.
Yeah, we will see why we included that one. So this is basically a health check endpoint. Normally you don't need it because in gRPC it's already implemented one. But this is an example. In the ping, I just want to ping the servers, and as a response, I want to some properties. But since I don't have anything to send, I need to include empty proto, unfortunately. And the empty proto is some basic types are already given by Google. It's basically an empty message. So when, even at the client side, when you are calling that ping service, unfortunately you need to create an empty from a new builder and build and send that response. This is a constraint, so you need to include a request response object for all the messages. And let's see how these things are generated. Since we run Maven clean install, and we will see, this is our source codes. Since we have two services here, one is ping service, as mentioned as service, and one on the greetings. So this is how it looks like the generated code. It's quite looking complex, but here are our messages. Like we see that greeting service stub extends some abstract stub, and no, not this one. Sorry. Yes. This is basically what we will gonna use, as we will extend this class and we will overwrite the implementations. This is the basic implementations. gRPC told you that in stack, if it's required, there will be provided some default. If they are useful, there will be some default implementations. For the services, is unimplemented error will be thrown from your service directly. For example, if you include this service without implementing any services, when a client called, they will not gonna have a big, like, not found kind of example, the exception. They will just get it unimplemented callback for their end. And this is our messages. One is coming from Google Protobuf because its package is different, and this is our one is coming from base, our error message, and our error codes or the ping messages. And I don't know if you guys see, we are including a parameter, Java multiple files. If it's true, then it will be, like, for example, error codes will be a separate class to be used somewhere else.
Yeah.
If you don't include this one, then the whole message will be squashed into a single Java file, which is totally okay to use. It's much more clear in that way. Okay, let's.
Can you show us which dependency in your Maven file, like plugin dependency to generated those classes?
Is on the let's
Do
see.
you have a plugin in your code?
Yeah.
It's in the plugin.
This is a plugin
Yeah.
that we mentioned. It's on the compile time. It generates the resources from the proto files. It reads them, and then after that it's uses
Generated classes, are they in the source folder? Are they generated in the
No,
source
they
folder?
are on the target file.
I have to move them
But
one hand
if
in.
I use them, can I
Why
use
you
them
do-
in my project?
But that's
Yeah, sure.
That's
You
for
just
the
will
client.
include
But
them.
the generated part are for the client, not for the server. You know?
But if they are if they are not in the sources, they are always in the targets.
Mhm.
On a clean project, it is not compilable, right? I have problems, errors. So I need to make an.
No, like this build is hitting at the compile phase. So before the Java code is compiled under the source folder, the class will be generated.
Before it will be
Yeah,
generated.
yeah.
Yeah,
It's a
but
Maven compile, not Java.
And like, to be honest, like, this is not the best use case. Like, this is an example
Because
project.
we had that in past, and we had that step to copy it to the source folder as well, so that when we download, we have compilable code in your IDE for your conditions.
Like what we followed previously is basically include the protofiles in the service at first phase. Then when you decided, okay, the protofile is good enough and supply everything what I need, then we just put the protofiles in a separate project and it will be just this plugin. And eventually the output will be a jar file. So we were creating a server and Java.
For the end jar, it's okay.
Yeah.
But for development, it would be nice to have in the source folder.
Then I
could be.
sorry, then I misunderstood everything then, because I thought the generated part is for the client and this is the server part, no?
No, both. Server code and client code will be generated.
Yeah. So the source code is about the server side, no? What-
Yes.
Yeah.
But
so-
in this example, since we will using the as a client on JUnit test, it's
okay,
included
only
in
for
code.
the testing purposes.
Yes.
Yeah.
Normally you don't need to generate the
Yeah. Then,
client code on the server side.
Maven compile is enough and you don't need to put them in the source.
It depends on your
Maybe
It depends on your needs.
use case. Okay, let's jump into JUnit test first without seeing any implementation. So we will see if it's working or not. This is a pretty straightforward Spring test. We are creating two steps. One is blocking and one is async. So it's just created by gRPC generator. And all you need to do is creating a channel object, which indicates the IP address and the port number where we are targeting the gRPC site. And we are basically building the client. And this is where I mentioned why I'm copying this one. This is what I mentioned. Use plain text, then gRPC will not. This is for testing purposes and it's more debuggable. I didn't dig into this one. But then you will have this, and when you go into that, they are saying that this is not for production use. This is solely for testing. Like basically, you can remove this one. It doesn't make any difference. And then we are creating our blocking and the future step here.
So the greeting service gRPC is generated with mail, right?
Yeah.
So it's in the target folder currently.
Yes. And there is no need to do anything else. You just create your step, and then in your blocking step, you will have three RPC methods here: greet or throw, and greet like steward. And all we do is just passing the request object and waiting for a response. Let's run this service, run this test, see what will be happen as the output. Now it's pretty slow. Okay, when we see our test code, we see that a couple of interceptors are executed somehow before our server code. We will see how it's been configured. And what we've done is, this is basically a protobuf file. And it's not super readable on the generated side. But when you say to string, it's just basically print out, not JSON, but something JSON-ish. It's quite useful in my opinion in this way. Let's see how we do the server implementation here. Like the client side is, as you see, it's just one line of code to call. You don't need to configure much things. On the server side, we are first extending our generated code, which is greeting service AMPL based.
So to ask again and again, but
Sure.
how does IntelliJ resource the generated classes? It shouldn't look to the target folder.
Why not?
You can look, it's not that well. If you check in the project settings,
Because it only checks, as far as I know, it should only check the
you can
source
you can
folder.
say IntelliJ will go to the sources in the target.
Okay, but it's
As far as I know, I didn't do any
I think it's
special
by default.
configuration.
I'm not sure.
checks target.
Yeah. So that's why I was saying you don't need to
Okay,
call.
I didn't know that.
Because
Like
I
this
thought
is-
that it was only
yeah,
checking
so
source
if
of
you
the-
look
Target
here
is
on
already
the right,
included.
on the right you see the source resources and
Okay, it's
Target.
added. That's why it finds it. It is
Yes.
added as a sort. Look,
Yeah.
target
okay,
is
so you-
excluded.
okay, yeah.
Target is always excluded in normal cases. So that's what you're thinking.
I'm not sure if it's always
Maybe plugin somehow this
Yeah,
Yeah,
maybe
it could
they,
be.
it is improved and now it
but
includes it.
even though it's better to add manually than to put in the production code because then you have to do code
yes,
review,
yes.
so it's
So
not
it's also a good way to
Yeah.
versionize it.
Yeah.
You see it in
Okay, let's jump into the implementation on server side. We are extending the service, so we all need to override the grid service. And this is how gRPC generate the code. First, the request objects, and our response will be inside the stream observer. So the use case on streaming services and like synchronous call or asynchronous call is quite same in that aspect. We are just fetching the name. We don't need to parse anything. Everything is parsed for us, de-encoded from the proto file. We get the name. We check if it's Viber or not. If it's not, we just build the response, and on next we will see the use case why we are using that. And after setting our payload, we are just putting on complete, so the stream will be closed on both parties. And if it's a Viber, then we are basically adding our error message, which we see on the base package. So let's test that one as well. So we are testing greeting for Viber.
No one likes this guy.
And we get the same response, like it's a wallet, like if it will be restores, it will be 200, okay? And we have the error code here with the description. Just again, pretty straightforward. But now we have another service, which is test greeting or throw. So in the working example with the Candas, I don't expect it to throw any exception. It will be directly the same response that we had before. No differences here. But now, when we call the service, the gRPC stack itself creates a status runtime exception. So this is like exactly as, instead of the idea at the Google is basically you are not calling a service. It's like calling a method in your project. So they simulate the same experience how it will be. So you can change this exception or you can change the status codes here. And in our case, it's like resource exhausted, which is coming from original gRPC packages, exceptions, is under gRPC core. So there are lots of basic or default error messages that you can use in your general, or you can, as I mentioned, extend it. So how we achieve this? In the grid response, we put our error message inside the proto response because it was already been pre-configured. But on grid or throw methods, we do something different. On the response observer, we put on error type, our exception. So this is specific for that, and if you are throwing an error, you don't need to call onCompleted because it will eventually close the streaming. Or on the normal case, you just put your response on next and you can complete your request as well. So pretty same usage. Let's jump back to have something different on the test. There's a new thing, test greeting for Trump. And guys, please keep an eye on here. Like we have 3 lines of metadata interceptor is run and logger kicked in, and somehow before logger finished, validator interceptor kicked in, and eventually logger interceptor puts something. But when we run it for Trump, It will be pretty different exception we will have. You see that the logger interceptor couldn't print the Trump message. And this has happened because this call is, for example, let's check our implementation. What we called here, greet message for Trump. Let's go to source code. That should be okay, right? If it's not Viber, we should greet him. So something in the gRPC stack is just cut this communication. For this, we need to jump on the interceptors and what are they. And also I would like to talk about how the configuration is happening on the service. So what we talk about is basically we are extending a generated class. And when we go over the implementations, we see that it's implementing something called gRPC bindable service. And since I'm making this one as a Spring service, so it's a Spring managed singleton bean. In the configuration part, I am just injecting all the bindable services are implemented as beans. So this is a pretty auto configuration. You can just keep this and you can keep adding new services to this. It will be automatically discovered and automatically be added to your gRPC service. And here we just basically, as a constructor field, after we get the bindable services, we build a server for port 9090. So our gRPC will be hosting on port 9090. And then we have a post construct. We just fetch all the bindable services, which this is not a good implementation. So we are basically binding all our interceptors for all our services. So if it's a generic code, then you can do it. And this method is working as a stack idea. So the last one you put inside will be executed as the first order. And you can pass data between the interceptors. So basically, for example, JSON web tokens, you are parsing it and you are getting the payload of the JVT and you don't want to parse it again and again. Then you include as a last one as JVT token parser, parse it, and then pass the information to the other, for example, authorization interceptor or the other one. You can pass easily your data. And then we are adding service to our server, which will be, in our case, the greeting gRPC service. And we are looking. And eventually, when everything is initialized, I don't know if you guys ever use the event listener. Spring is basically using events, so it will be fired after everything is started. We are just starting our server, and we are registering a shutdown hook. When we stop our execution, you see that here we are using a shutdown now, which is not lame ducking, doing lame ducking, and there is this is not recommended to use on production level. You normally use the shutdown method to lame ducking. This is a forcing, but it's okay for this example.
Going back to the interceptors, how do you distinguish between input interceptors and output interceptors, or there is no distinction?
Like there are that you can put interceptors for both client side and server side. But if you mean that
still server side, you can have incoming. For the incoming request, you can have interceptors. But also for outgoing response, you can have interceptors.
You can achieve whatever you want on that aspect, on the way how it works, because on the gRPC service, for example, we have request and response here. So all the methods are void basically. So there is no need to tie something after the call or before the call. So at the interceptor points, if you put, like we will see it. Like for example, this is for your question. In logger interceptor, I want to log the code.
Yes.
Let's run a better example here.
But that means it goes also on outgoing response.
I am just registering a callback here.
Yeah.
And basically when the message is parsed on gRPC stack, it will not be parsed in this stage. Okay, like for example, what happens here? We first kicks in metadata interceptor. It executes, and then logger.
Yeah.
But logger just print out this message, the full method name. Then
Yeah.
it passes, but we are registering a callback here
Mhm.
for when the message is parsed from the proto file into the Java file, execute this code. At that moment, it's printing out our names. So validator interceptor will be kicked in
Okay, so-
before that. So there is no discrimination
There is no
between
distinction
yeah.
between.
pre and post. But you can achieve everything. It's quite hard sometimes,
Yeah, it's-
but after you get used to it, it's super easy. So in our example, this is our first interceptor, kicks in. It's just cache the metadata from the basic, like we are implementing the server interceptor. And we are getting attributes as the caller IP addresses, remote address, and the server addresses. This is doing nothing much, but you can make your custom interceptor. What we are using in GrabUp, for example, we are generating a UUID at this stage, and we are including in the stack. So whether that request going to a different microservice or whatever, eventually when you collect all the logs and when you look at the UUID, you will see the trace on the other services as well.
The correlation I
Yeah.
These interceptors work on strings as well, right?
Yes.
On every message.
But no, not every message. It's just when it's initializing the connection. And this is the second one. The
So if there is a string,
Yeah.
because we can define string functions,
Mhm.
then how will the interceptors will
I
work?
don't know.
For example, I will send 100 messages.
Yeah, it's
When I will read the responses, can I read the responses and intercept?
it's a
them?
batch.
How will it work?
It's the first stage. For your first request on that stream, it will be executed, please. But for the rest, it will not going to be executed.
So I can.
As far as I know, maybe I don't know. Maybe there is a way to do
Because
that.
maybe I want to log responses. Let's say, for
Mhm.
example, then that
Yeah,
should
it's
be
big
somehow.
because it's a kind of batch processing. So yeah, I don't know.
And in here, we basically put the method name, and we are, as we mentioned, this one, we are creating a callback. When the message is parsed on the gRPC stack, it will gonna be logged, and there is a validator interceptor. Let's jump back our example for Trump one, and in here, what we do is quite different. We are registering. This is not a good way of doing this because since this interceptor is registered for all the services, I need to check if the instance of message is this one or that one. So normally you can make this validator instead of greet service validator interceptor maybe, and then you can just edit for that one. So for now we can ignore this one. Basically when the message is parsed, we are looking at it. If it's a trump, then we close the server call at this moment. What does it mean? Then it will not gonna be propagated to under the state. After this stage, it will be not even the methods will not be gonna invocate it. This is the main key points of gRPC that I mentioned. All the requests are be cancelable on every stage. Even a client can cancel its previous request, or it could be canceled in at some point in the code. And this was the Trump case. So our call was ended and the communication is closed at the interceptor phase, so it doesn't propagate to down. And let's continue.
Interceptors primarily like filters in.
Yeah. It's same, I think in the REST, for example, you can put interceptor as well for a REST request as well. And this is a async one. So as you see, our implementation on the greet service is nothing different than the other one. And now we will have a listenable feature, which the blocking one is the get call here. So as you can imagine, this is a happy one, so it will gonna return the same response. But in this one for Viber, when we do the call, we don't get any exception, but when we try to get the response, we will have the exception. It's pretty same as this one. Again, we will have the status window. Yeah. And now we have the example for a streaming service. What we will do is in this example, we are depending on the server side to close the communication. Like for the test, I need to ensure I get the enough response. Like I'm just counting how many responses will I get. In our case, I made it special for 30 requests we will gonna be receiving. So the call is initialized, and you will see that on the execution side, our interceptors are run as it is, and we have a couple of responses back. And this is just an iterator implementation. If it has next, then we will have more response coming on the server side. Let's see the implementation. Oh, I did it. And now it's quite same. Our method signature is completely same as the blocking one. And we will get our response. We will check if it's Viber or not. So we can throw an exception on streaming service as well, which will close the communication again. Otherwise, we are just iterating 30 times to send the response back. And I put some waiting here to see in action. And after our streaming is finished, on the server side we are sending on complete. Otherwise, if I don't use this one, like let's try commenting out this, and our service, the test will be executed. Since the communication will not gonna be closed, we'll probably send 30 requests and then it will just be hanged, like this one. It will not gonna be finished. So we can post more on the server side if you want. Is it clear for you guys? So this is the same streaming service. Now we are coming with the Viber, and it will just send the exception and it will be closed immediately. Even if you comment out the onComplete method here, since the exceptions will gonna directly close the streaming, we will have the same response right now. And we have another service, which is ping service. And as you see, we didn't create the service for that. So basically, it will not be added to our configuration as a bindable service. So let's see what will happen if we test that one. And on the gRPC side, we will again have the same response. Our exception will be again unimplemented. And since now service is not included as interceptors, it will not gonna execute the interceptors as well. And let's jump on the performance. I think all of us were wondering how it's compared with the REST services. So I have quite same example here. We have a controller, Spring controller, which is a greeting resource. The case, the business logic is same. If Viber, then it's an error message. Otherwise, it's a greeting message. And in our tests, and even at this level, for example, you will see on the server side, when you are using protofiles as generated code, the server is super simple. But for REST service, you need to create your request objects and stuff, which is kind of boilerplate code. Looks like a boilerplate if you compare with the gRPC one. And for the performance test, I do a special thing here. I'm not using JUnit 5, So I cannot order which test will be run first. And by the method naming, I had test 1, test 2. So basically gRPC test will run before than the rest one. And we have something here, dirty is context. So for both requests, Spring will be initialized from scratch. So let's run, see the impact. This is not a real performance test because it should be run on a metered JVM. However, I'm pretty sure that we will see really clear difference. So we are seeing lots of logs because each of tests is executed 1,000 times. And let's compare how it will be performing. It's super strange now. gRPC request, I don't know if it's related with the communication here. I will run it again. Normally we should see vice versa.
It's about the interceptors. You lose time in the interceptors, I guess.
It's like normally when I run this code at my home, if it's 5 seconds for the rest, it will be like 2 or 3 seconds. I don't know why it's performing
Just remove
like that right
remove the
now.
interceptors. Just try.
It's like elections in Turkey. We can continue until Delta one wins.
Let's try it again. You guys can run this project again with a decent connection, I don't know.
Yeah, 3 seconds.
Maybe it is because of test framework is initializing to do something.
No, I definitely tried this yesterday. And
What with the
didn't
interceptors
come-
enabled? Are you sure?
Yeah.
Because
It was enabled.
At the end, you are encoding it in JSON when you are reading it, no? With the interceptor, so you lose time. then.
Yeah, sure, of
So
course.
I wouldn't expect it to was faster.
There was a property that you said, do it with open text, something like that.
Yeah, it's still okay. Like I didn't change anything in the code from yesterday to today. I mean,
Candas.
no.
I run the performance test on my machine.
Huh?
The gRPC takes more than 2 seconds. The rest takes 4 seconds.
This is normal. I don't know what's happening in my workstation
You
right
have
now.
the latest version, the version that is in GitHub or in Big, whatever you have.
In Bitbucket,
Maybe
yeah.
you have a different version.
No, it's same. It's same.
Yeah, gRPC takes 2 seconds. But yeah, exactly.
Which is a test you yeah?
No, not this one. It's not a
My
stream.
machine
No.
almost took the same purpose.
Let
3
me
with 5
Like
seconds.
this is not a proper way of performance testing.
Yeah.
Like normally you should use a meter JVM, and we are depending on the
Yeah, but
Spring
still
runtime.
it shouldn't be. What's the test name?
It's performance test.
Performance test.
Most of the time is going for split boot up actually.
Yeah.
No, but it's
That's
not
right.
calculated. It's on the.
Isn't it?
No, I don't think you are calculating.
I think
On the
it
test
starts
perspective,
when
I
it
don't-
Because
starts
he is counting the start of the execution of the test and the end of the test, no? So
Or maybe it's a
No,
matter of
yeah.
caching because you start the GRB test first, so it takes much time to start.
But
Later
it-
on, the one
there is a-
one will be faster.
there is a
Try to
perm-
push the order,
That can
like
be used.
naming 2 to 1,
Yeah.
1 to 2.
But there is a thing I put here, dirty's context. For each test, Spring will be initialized
Yeah,
from
but
scratch.
this is something that you your machine's processor. When you start the first time, you start
Let's
from clean, so you have to cache few things.
And also
Let's-
dirtiest context takes time as I know. Dirtiest context also takes time. As
Why
I
do
know.
you need it?
It's if you put that dirtiest context, for example, you have a stateful Spring service.
Yeah.
then a test will modify it, and you don't want to see it on modification on the other test. So now I switch the execution order. Now the rest is running first.
Meanwhile, let's sneak throws.
Now it's same. I don't know. Sneaky throws is coming from Lombok library. So if you use this one, you can don't need to add throws declarations on the test, which is a super easy thing, I think.
That's serious.
Okay, we can try it later on.
Yeah,
Let's.
I would put log when you start the test itself,
Mhm.
and at the end of the test, and then you can see the
Yeah,
difference.
we can do
That's
that
more,
as well.
yeah, if you want to.